All right, so the first use of Maclaurin series that we got is to find out the composite functions Maclaurin series. Let's say I have been given the Maclaurin series for cos x, and we derived in our previous fragment is, okay, cos x Maclaurin series is 1 minus x squared over 2 factorial plus x raised to 4 over 4 factorial minus x raised to 6 over 6 factorial, and so on. And if this is given to you, let's say here, if I plug a k as 0 here, you'll notice that I get my first term as 1. If I plug k as 1, you'll notice that I get my second term, and so on. So if I plug k as 1 here, I'm going to get, if I minus 1 to the power 1, 2 factorial times x to the power 2. So that's what it is. It is, you can see clearly, negative x squared over 2 factorial. So anyways, this is not a question. This is already we derived, and in case if they ask you to derive, you can definitely do it. But what is really interesting is here they are expecting us to write down some of the answers, like such as like cos 2x. When you write the Maclaurin series, you already know the Maclaurin series for cos x, and they're expecting you to find the Maclaurin series for cos 2x. So logically, before I ask you the question, it might be clear in your mind what I'm asking. That, okay, if I already know the cos x series, I'm finding out the cos 2x. X is actually being replaced by 2x everywhere. So I'm just going to write down 1 minus, you replace x with 2x, which is 2x square over 2 factorial plus 2x raised to 4 over 4 factorial minus 2x to the power 6 over 6 factorial, and so on. So when you find out the Maclaurin series for cos 2x, this is how you do it. And if you wish to simplify, you can simplify this. But now let us say I wanted to find out Maclaurin series for cos of minus x. So this x actually is going to get replaced by minus x. And if I want to find out Maclaurin series for cos x squared, so if I want to find out Maclaurin series for cos x squared, I'm going to replace x with x squared. And I want to just quickly create a question, and that can give a sense of why do we use Maclaurin series. So I want to find out, let's say, cos of x squared. So I'm going to say, okay, cos of x squared is actually 1 minus x squared the whole square over 2 factorial plus x squared the whole raised to 4 over 4 factorial minus x squared to the power 6 over 6 factorial, and so on. Now when I simplify this, it is 1 minus x to the power 4 over 2 factorial plus x raised to 8 over 4 factorial, and so on. So what I'm going to ask is, like, lots of times when you're asked to do the integration, okay, so when you're asked to calculate, let's say, integration of cos of x squared or something like that. So let's say you're finding cos of x squared integration. Okay, now cos of x squared integration, I'm very interested to see how do we do it without using calculator. Now this is not possible without technology. So I'm going to demonstrate, like, both the integrals. Like, obviously this one is an approximation, so I'm going to integrate both the functions from 0 to 1. Actually, I'm going to use this one, x raised to 4 over 2 factorial plus x raised to 8 over 4 factorial, and of course there are terms after that, but I'm not considering them. So let's say this is what I have at this stage. Now this one is, I'm going to find out integral, and this one I'm going to find out the integral using both technology and see how close they are. So that is something which is a point to be watched here. Okay, so here we go. In case if we have got, let's say, the two functions that I'm showing here, I'm now going to calculate the area using, obviously you can see here the interesting part is the polynomials that are appearing here. Now you can see that they both are pretty close approximation, and I'm going to integrate both the functions from, let's say, 0 to 1. Okay, now I'm going to first deselect my first function. So if I say gsol integrate, and I calculate the area as 0 and 1, it comes to be around 0.9045. Now I'm going to take my second function, which is the polynomial function, and this is my polynomial function. So let's say gsol integrate here, integrate 0 and 1. So if you see, it is 0.905 was that, and it is 0.9045. It is pretty close, these pretty close answers. So both the approximations are actually very handy here. So to estimate the integral or some of the values that cannot be done without having, like, technology. So that's where Maclaurin series is one of the very interesting concept that is applied. I'm going to take now one of the a really big IB question in the next fragment to demonstrate some more properties about the Maclaurin series.